In the garage today, we have a 2005 Chrysler Town & Country with a little over 94,000 miles on it. It has a 3.8 VIN-L engine. The owner is concerned because the check engine light is coming on intermittently after she has been on the highway for a few minutes. We checked the trouble codes and found code P0406. This indicates the EGR voltage is high. This vehicle has a digital EGR valve. The only test procedure we could find for this code involves activating the EGR valve with the factory scan tool. The problem is that most technicians do not have the factory scan tool at their disposal. So what now? After looking through the repairs on Identifix, we have a 98% probability the EGR valve needs to be replaced. But it would still be nice to know if the part is defective before replacing it. We decided to activate the EGR solenoid manually and scope it to try and find the problem. The pinout looks like this. Pins 2, 3, and 4 are power and grounds. Pin 6, the activation control, and pin 1 is the EGR signal. We first checked the power and grounds, and they were all 4.95 volts. This looks good so far. Then we connected the red trace of the scope to the number 6 pin, the EGR control, and the yellow trace to the number 1 pin, which is the EGR signal. We then tapped a grounded jumper wire to the back probe going to the EGR control pin 6. This action activates the EGR solenoid. Look at the resulting scope pattern. We have a nice digital pattern showing the activation on the red trace, but the yellow trace signal, which should also look digital, is uneven and broken. This was done on a warm engine and now proves we do have a problem with the signal portion of the EGR. The entire EGR valve is defective and needs to be replaced. But what is going wrong inside the sensor portion of the EGR valve to cause this problem? A state-of-the-art automotive testing lab at our disposal sure does come in handy. We took the defective and a new EGR valve to the lab for testing. First, a wiring harness was connected to each of the EGR valve terminals and slipped through a hole in the side of the oven. This harness will allow us to control the EGR valves while they are being heated. Then the valves are placed in the oven, which is set to 141 degrees Celsius or 285 degrees Fahrenheit. This is done to simulate the heat generated under the hood of the vehicle. After about an hour of soaking in the heat, they were tested at a 0 to 29% duty cycle and 128 Hz. This is the new EGR valve signal. As you can see, it is a crisp, clean digital signal. This is the defective EGR valve signal, and as you can now see, it is very uneven and choppy. But what is going wrong inside the position sensor? We carefully disassembled the sensor from the defective EGR valve and took it apart to find the answer. After examining the board under the microscope, we found the conductive silver has worn through at the point of contact, and it is also separated. The problem comes down to a design flaw in the pressure contacts and in the curing process that adheres the conductive silver to the board. At Wells, we are continually looking for ways to improve the original design of vehicle electronic components. Our engineers are developing a fix for this problem right now. We are totally committed to offer the best parts available. Here's a tip. When removing the old or installing the new EGR valve, remove the top bolt and loosen the bottom bolt. Then tip the EGR valve down to hand remove the bottom bolt. It is a tight fit, but you can get the bottom bolt out and back in without removing the alternator. See you next time in the Wells garage and maybe one of our labs too.